Here's a review of trigonometry. So we're going to go over several different things. You need all of these different things in order to do the scavenger hunt today. Hopefully you remember most of them, but you can also review back to this video as we're going through learning about trigonometry. So the first thing is basic trigonometry. So when we have a right triangle, we use something called SOHCAHTOA, or the sine, cosine, and tangent. And sine is always related back to the opposite and hypotenuse. So if I know the angle, I can find the sine of the angle, and it's going to be equal to the opposite over hypotenuse. So here's my angle, here's my opposite, and then this is always going to be, the slanted line will always be my hypotenuse. So if I have a problem like this, so I don't know what x is, but I have the opposite of x and my hypotenuse, I can solve the problem like this. I can find the sine of x, or theta, is equal to the opposite over the hypotenuse. It's going to be equal to 8 over 10. So since I don't know what the angle is, I'm going to use the inverse of sine. So sine of -1 of 8 over 10, and then I just plug that into my calculator or into Desmos, and it ends up equaling, still trying to find x, it ends up equaling 53.13 degrees. So once I get to this part, I just plugged it right into my calculator. Another example is I have the angle, but I don't have the hypotenuse, so I can still use my sine. So I would do sine of 15, make sure your calculator is in degrees, equals 8 over x. So I'm going to multiply both sides by x. So I get x sine of 15 equals 8, divide by sine of 15, basically just moving things around. So x equals 8 over the sine of 15. So I put that in my calculator, and I get 30.91 centimeters. Third is if I know the hypotenuse, but I'm going to see my opposite side. So I would find the sine of 25 equals x over 19. Multiply both sides by 19. So I get 19, the sine of 25. Plug that in my calculator, and x equals 8.03 centimeters. So the next one is when I would use cosine. So if I have the adjacent to my angle and my hypotenuse, I would use cosine, or if that's what I'm looking for and I know my angle. So the first example is I'm looking for the angle measured. So I know the cosine of x is going to equal the adjacent over the hypotenuse. So in this case, it's going to equal 7 over 20. So I use the inverse of cosine. So x is equal to the inverse of cosine of 7 over 20. Put that in my calculator. I get x to be 69.51 degrees. Next one, I'm missing the hypotenuse, so I can find the cosine of 35. It equals the adjacent over the hypotenuse, so it's going to equal 12 over x. Multiply both sides by x. Then I divide by the cosine of 35. So I get x equals 12 over the cosine of 35. Put that into my calculator. And I get x equals 14.6. Third is if I don't know my adjacent side. So I can do cosine of 10 equals x over 8. multiply both sides by 8. So I get 8, the cosine of 10 equals x. Put it into my calculator, and I get 7.887 meters. So now I'm to the TOA, or the tangent. So this is if I have the opposite and the adjacent. So I don't care about my hypotenuse. So I have that my adjacent. This is my opposite. So in the first problem, I have the opposite and the adjacent, and I'm looking for the angle. So I would use tangent. So tangent of x equals the opposite over the adjacent. So it's going to be 8 over 6. So I'm going to use the inverse. So I just plug it into my calculator, and I get 53.13 degrees. Now I have my angle, but I'm missing my opposite. So I'm going to do the tangent of 50 equals x over 3. Multiply both sides by 3. I get 3 tangent of 50 equals x. So I get 3.58 centimeters. And now I have my opposite, but I don't have my adjacent. So I'm going to do tangent of 5 equals opposite over adjacent, so equals 9 over x. Multiply both sides by x. Equals 9. Divide both sides by the tangent of 5. So I get x equals 9 over tangent of 5. So x equals 102.87. Okay, so the next thing is when I don't have a right triangle and I have an isosceles triangle, so something that's not a right triangle. So I want to think about using the law of sines or the law of cosines. So in this case, when I think about it, I label my sides. So I know that I'm thinking that this is angle A, angle B, and angle C. So then across from each one, I have sides A, B, and C. So basically I'm setting up proportions. So I know that A over the sine of angle A equals B over the sine of angle B, and also equals C over the sine of angle C. Or I could flip those around. I could put sine of A over side A equals the sine of angle B over side B equals the sine of angle C over side C. So they always have to be like the ones that are across from each other. So you want to think about them being the sides that are correctly across from the angles. So when I'm thinking about this, I'm thinking side A divided by the sine of angle A has to be equal to side B divided by the sine of angle B, which has to be equal to side C divided by the sine of side C. So when would you use this? So again, you're going to use this when you don't have a right triangle, but when you use the law of sines, this is the case when you're going to use it. So if you know 2 of the sides in an angle, or you know 2 of the angles in a side, you're going to use this to find your missing sides and angles. Okay, so an example of this would be, so say I wanted to find the side length C. So I know 2 of my angles and a side, so I can use that to find C by knowing that I also know 1 of my sides. So I know that the sine of 35 over 7 has to equal the sine of 105 over C, because they're across from each other. Okay, so then I just cross multiply. So I'm going to do 7 times the sine of 105 divided by the sine of 35. Equals C. So when I do that, I get that C equals 11.8. So I just put that right in my calculator. Another example is I'm looking for angle A. So when I do that, I know 2 of my sides. These are the ones that match up. So again, I know the sine of A over 4.7 equals the sine of 63 over 5.5. So I'm going to cross multiply. So I'm going to move down my, so I know that 5.5 times the sine of A equals 4.7 the sine of 63. Divide both sides by 5.5. So I get the sine of A equals 4.7 sine of 63 divided by 5.5. So then I have to take the inverse of sine. So to figure out what the degree is, in my calculator, I'm going to plug in the sine of the inverse of 4.7 sine of 63 divided by 5.5. Now, I could have figured that out earlier in my calculator, or I could plug the whole thing in. It all depends on how you want to set it up. So the next one is the law of cosines. So this is when you don't have like the opposite sides and angles of things. But when we draw it, this looks exactly the same. So we want to envision that this is A, this is little a, this is B, side B, angle C, side C. So when we're thinking about it. So the trigonometric functions of law of cosine in words is the square of a side of a triangle is equal to the sum of the squares of the other sides minus twice the product of the other sides multiplied by the cosine of the angle. So when would we use this? We're going to use this if, let's go down a little bit to say when we would use this, and then I'll show you it as a formula. If you know all the sides, you can use it to find missing angles. If you know an angle and 2 sides, you can use it to find all the angles and all the sides. So the difference between using this one is in the last one, you needed to have angles and sides that matched each other. This one, you don't need that. They don't need to actually match up. You just need to know one of the corresponding. So the formula for this is if I had, and C is just, it doesn't actually mean side C. We can make any of them A, B, or C, any of the angles A, B, or C. So C squared has to equal A squared plus B squared minus 2 times A times B times the cosine of angle C. So angle C and side C just have to be across from each other, and then you use the other 2 to fill in the rest of the formula. So for example, if I was trying to find C, so notice I have the one directly across from it. So when I look at this, I can make either one of these A and B. So I'm going to do A, B. So I'm going to do C squared, because I don't know what it is, equals 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of 37. So in order to solve that, because I actually put it all into my calculator, you're going to find the square root of both sides. So in my calculator, I did C equals the square root of this whole thing. And when I did that, I got C equals 6.67. That's my answer. So then another example is I'm trying to find the angle measure this time. So we're going to use the same thing. So I'm going to make this A, B, and then this one C. So I'm going to do 18 squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of c. Because I don't know what that is. So then I just start to solve. So the first thing I'm going to do is get the cosine all by itself. So I'm going to get 18 squared minus 9 squared minus 12 squared. And then it's going to be all divided by negative 2 times 9 times 12. And that's going to equal the cosine of c. So then I need to do the inverse. So basically, I'm just going to put in my calculator the inverse of cosine of this whole thing. And that's going to be the answer. So it ends up C is approximately 117.27 degrees. Okay, so the last thing that you guys have to kind of remember is the special right triangle. So we have two special right triangles. The first one that we're going to talk about is the 30, 60, 90. And if you know that it's a 30, 60, 90, you know that the side opposite 60 is going to be x times the square root of 3. The one opposite the 30 is x, and then opposite the 90 is 2x. So knowing that, we can use it to figure out all of our different sides of our triangles, if it's a 30, 60, 90 triangle. So some examples would be, if I have a 30, 60, 90 right triangle, and I know that the side opposite the 30 degrees is 4, I know that this is 2 times 4, which is going to give me 8. And I know that this is 4 times the square root of 2. Or 3, sorry, square root of 3. So for the next one, I know that this is 10. So I know that the one opposite 30 is half that, so it would be 5. And then this one would be 5 times the square root of 3. So this one, it tells me that the one opposite 60 is 7 the square root of 3. I know that this side is 7, which means that this one is 14. So word problems. So problem 4 says a television is measured by the diagonal. So when you buy a 60-inch TV, that's really its diagonal. What is the size of this television? So it's a 30, 60, 90 right triangle. If this is 24, this side has to be 48. Just multiplied by 2. How far from the base of the building is the car? So here's the base of the building. Here's my car. So I know that if this is 18, this has to be 18, the square root of 3. The next special right triangle is a 45, 45, 90. Special right triangle is an isosceles triangle. So these two sides are equal to each other. And then the third side is x times the square root of 2. So if I'm looking for this and I wanted to find the missing sides, I know that this is 5 and this is 5 times the square root of 2. If this is 8 square root of 2, I know that these are both 8s. And this one's a little different because the answer is 12, which means that I had to multiply a square root times a square root to get it. So I know the square root of 2 times the square root of 2 is going to be 2. So 2 times what is going to give me 12? And it turns out it's 6. So that I know that this is the 6 the square root of 2, and this is 6 the square root of 2, because this is always x times the square root of 2. So if this is x times the square root of 2, that's going to give me 12. Because 6, so if I think about it, 6 times the square root of 2, the square root of 2 is really just 6 times 2, which gave me 12. Okay. Problem 4, what's the distance between first and third base? So it's a 45, 45, 90 degree triangle. I know these are both 90, so it would be 90 times the square root of 2. And then 5 says the perimeter of a square is 28, which means each side is 7. What's the length of its diagonal? It's 7 the square root of 2. Okay, so make sure you're using all these different note sheets and foldables in order to do the scavenger hunt that you're working on, it's going to help you out quite a bit.